with our inequalities, we've got to make sure that we're testing a point and shading it. So let's have a look at number 1. The nice thing is this is in slope-intercept form. This is on our notes page. So I have a y-intercept of 2 and a slope of 1/2, and the only other thing I have to think about is this going to be a solid line or a dashed line?
Dash.
Dashed, good. So I'm going to start at 2, and I'm going up 1 and over 2. And since I'm looking for intersections, I want to get as many of those points in as I can, because that's probably going to be where stuff's going to cross. So get my dashed line in here. Guess that's kind of okay. Now, I still have to shade, so I've got to pick a point that's not on the line. Which one makes the most sense? 0, 0, right? The easiest one. So I'm going to test 0, 0. So if I plug in 0 for y and 0 for x, 0 is less than 1/2 times 0 plus 2. Is that true? Is 0 less than 2?
True.
That's true, right. So if it's true here at this point, I'm going to shade everywhere below, but I'm going to just do a light shading on this. Don't get too crazy, because we've got another line to put in. Okay. Colored pencils would be really good here, but I don't seem to have any. Okay, so this was my test for that one. Let's graph this guy. So I've got my 5 is my y-intercept. My slope is going to be down 2 and over 1. I can see where these guys cross, so I'm only going to get a couple points in there. Solid line or dashed line? Solid. Right. Now my bird example I don't really think works here so well for this. So now I need to pick a point that's not on the line, because I'm going to shade for this line as well. Yeah?
So what happens if it's like it works on both sides of one of the lines, but not on both sides of the other line?
Well, but it only, okay. The shading only works on one side of this line. The shading will only work on one side or the other of this line. We don't know which one yet, right? But what's going to happen, we think, is there's probably going to be a place where it's true for both, double shaded.
That's what I was asking.
Okay. It can happen where there's no double shading. It's possible. It happens sometimes. Okay, so I'm going to pick 0, 0 again as my test point because it's not on this new line. And I'm going to plug that in here. So I'm going to say, is 0 greater than or equal to -2 times 0 plus 5, which cancels that. Is 0 greater than or equal to 5?
No.
No, that's false. So if it's false here, I'm going to have to shade on this side of the line. Now, what we're looking for is where is it true for both, and that's going to be where it is double shaded. This is where the points are that are true for both inequalities. I think I did check the test point in each inequality up here, so I think I'm good there. So these guys did what that asks us to do. All right, let's look at number 4. Is everybody good with that? So where it's single shaded, it's true for one or the other. Where it's not shaded at all, it's false for both. But where it's double shaded, it's true for both. That's what we're looking for, the double shaded. Let's look at number 4. So when we have a question where it says x is greater than or equal to -1, where is x equal to -1? It's going to be here, right? And it's going to be a solid line everywhere above and below. So I'm doing the bottom one first here. Now, where are the x values bigger, greater, or equal to -1? The right or the left?
The right. Wait, greater than -1?
Yes.
Oh, the right. I mean, to the right.
To the right, okay. All right. Good, because I was thinking that we'd have to put you guys in like a boxing ring.
Wait, say it again.
Where are the x values greater than -1?
Greater than -1 to the right.
Right. Did I say less than? I don't think so. That's what I thought. So these are all the values that are greater than -1 on this. So we don't really use a test point here. You can just use what you know about numbers for that. This one, though, this one would be a good one to plug zeros into, I think. Both are solid lines. So if I plug in 0 for x, -y is less than or equal to 2. But we don't really want to consider the inequality here. What does y equal when x is 0? -2. Right, -2. Where'd I go there? So if I divide both sides by -1, however you want to do that, I get y is less than or equal to -2, but what I really want is just that 2. And I've gone and written on my thing here, and that's not good. Okay. So now if I plug in 0 for y, that's just x is less than or equal to 2, because the y cancels out. So that's my 2 there. So those are the points that I put in. 0, -2, and 2, 0. This one I do need a test point. What could I pick? 0, 0. Yeah. So if I plug in 0, 0 right here, is 0 minus 0 less than or equal to 2? Is 0 less than or equal to 2? That's true, right? So this is going to shade this way. So where is it double shaded? Right in here. Are we okay with those, you think? Okay, let's flip to the inside. Let's look at some of the harder ones, because I think the harder ones are where you have the system of equations, but you have to write the inequality. Let's look at this one. Let's take this guy here as our first inequality, this horizontal line. Let's look at this one as our number 1. How would I write that as an inequality? Is that going to be an x or a y equal? Y, correct, because it's horizontal. What does y equal?
-3.
Right, y equals -3, but that's not what we want, because this has to be an inequality. So where is the shaded part here, above or below for this one? Below. What are the y values below this? Are they larger or smaller?
Smaller.
Smaller. So this is going to be y is less than or equal to -3, because we have a a solid line there, right? Okay, so that one's done. This one, I'm going to use slope-intercept. I know that it's a greater than or less than, but I don't know which direction that's going to be. So I'm going to say y, and I'm going to leave some space. My intercept is 2, and my slope is up to, looks like up, what is it? 2, 3, 4, 5 over 3. Oh yeah, no, that's like a up 5 over 3. Now, so what I did is I used this point here and this point here, and I counted up 5 and over 3. Now, I can't leave it this way. I have to put the inequality in, but I don't really know where it goes. So I pick a point that's in the shaded region, something that I know is true, and I plug it in. So can I use 0, 0? Is that in the shaded region for that line? Yeah, let's use that one. So if I plug in 0 for y and 0 for x, then I've got to put in the inequality that makes that true. I'll do it up here. So 0 or 2, which is bigger? 2. So this is the direction of my inequality, and I'll bring it down there like that. Okay? How does that work for a couple of examples? Are we okay with that? All right. So one of the things that I'm seeing here, I really like what we've been doing with the curriculum, but there's a lot of problems. If you did all of these and then I sent you home with all the other problems, you might be looking to hang a teacher. Right? Perhaps. See, you're laughing. I'm worried about you now. Okay? You've already thought about it. Okay? So, here's what I'm going to suggest. Use these if you need them. I'm going to give you the assignment. This is what I really want you to work through. Okay? And we'll take a quiz in a minute.